Thank you so much for coming to this talk. I'm excited to be a part of an AI for Good Power Hour, Power 3 hours. I think we've got some great talks coming up in this block. And I have to say, it's going to be a pretty non-technical talk. The thing that I was most interested to do coming here when I was writing this for O'Reilly was to say, could we kind of open up the box on ways we're seeing people using AI for good, what that might really take, and then kind of just get a discussion going, kind of hear what everyone else is seeing on the front lines, what roles we all play in it. So it's a broad-ranging talk and talk about a lot of things. And it's kind of a talk in 3 parts. It's basically what's cool that we're seeing, what does it really take to make those cool things happen, and then the part I'm most interested about, what are we all going to do next? So that's kind of the setup. And just sit back and enjoy the buffet, and I'll try to leave enough time so we can actually talk about stuff at the end. Yeah, come on in, plenty of seats. So you got to start every AI or data talk with the same couple slides, right? So obviously starting this one off with a poem, like everyone does. I love this poem. How many people have heard All Watched Over by Machines of Love and Grace? Wonderful, couple. Well, good, you're about to get to hear it. So in lieu of music, you're going to hear this, which is this great poem in the 70s that goes, I like to think, and the sooner the better, of a cybernetic meadow where mammals and computers live together in mutually programming harmony like pure water touching clear sky. I like to think right now, please, of a cybernetic forest filled with pines and electronics where deer stroll peacefully past computers as if they were flowers with spinning blossoms. I like to think it has to be of a cybernetic ecology where we're free of our labors and joined back to nature, returned to our mammal brothers and sisters, and all watched over by machines of love and grace. Now, I still can't tell if Brodigan was being sarcastic. I have to believe there's a little bit of a wry tone to this. But I love this poem because it's such a fantastical image, right, of computers and robotic deer grazing in the meadow and all of us being free of our labors and joined back to nature. But the crazy thing is, it feels, walking around this conference, like we're at a cusp where this isn't that crazy a world to be talking about. And for all of Brodigan's sarcasm, I think there's kind of a beautiful sense to this, if you can take the optimist in you to it, and to say, wouldn't that actually be wonderful if we could have this merging of technology and society in a great way? And so the question is, how do we do that? And the thing that, of course, just as a quick recap, the last decade has brought us so close to this, right? We've created more cell phones on the planet than people. iPhone came out in 2007 or something. We've started instrumenting our bodies with instrumentation and sensors. And increasingly, all the advances that make this conference possible are showing computers that can do such awesomely new, sophisticated things, beating us at our own games, creating incredibly polite and creepy robots. It's incredible. It's all happened really, really quickly. And it's happened because we've been on this quest to basically digitize our world, right? We've created this massive nervous system of connections. And that now allows us to get all that data to either learn new things or optimize over totally new ideas, right? And that's what's so exciting to me. I know everyone in this room probably knows it, but walking around the halls, it's sometimes important to step up from the business lens of AI as business opportunity, and truly AI as a human opportunity. And that's so awesome. So the thing that's really crazy is for the last couple of years, we've gotten to this point. We're at that verge of asking, what could we learn about our communities and ourselves? How could we optimize the species, so to speak? And so far, the vast amount of work that we've done has been in solving incredibly first world problems. So a lot of us have devices at home that, can pull up Stranger Things with just a voice command instead of, remember when we used to have to click a button? Oh, no. Oh, God. I'm mad. Spencer, can we, from here on out, AI this, please. This is horrible. I got to press. Right? It's and I'm being a little bit facetious. I have these in my home, too. But it's there's so many challenges facing us. How would we actually take this incredibly new technology and apply it to social impact? And first, technologists, we can do a lot. I have to put this slide up because Disrupt is happening just across town this week. And I was technologists could solve this. But we're still solving a lot of the same problems. Disrupt's hackathon last year, the winner had a tool where you could find the item on the shelf of the store that Alexa had recommended. So it's oh, what a pain, you don't know where it is. We can solve that problem. I'm going to say this tongue-in-cheek because we do a lot of great things too, but it's obviously not just going to fall to the tech. But the thing that's really been dramatic that I don't know that everyone necessarily grasps is that social organizations are becoming these kind of data and AI companies. And so I always think of groups like this, Medic Mobile, who are a group that delivers healthcare via cell phone. So they go out into the field, they send these community health workers who volunteer to go door to door, and they take readings of symptoms, they provide treatment, all on the cell phone. So they've got all this digital data pouring in, but they're really not really using it for much, right? They're using it to count things, they're using it to understand some of the basics, but they could be deploying machine learning to, predict early warning signs or detect early warning signs of outbreaks. They could be optimizing where these community health workers go. There could be this whole supercharging thing going on so they could do more good, except they have just no one help them do that. There's not a lot of machine learning and AI people just running around in nonprofits, especially when you see articles like this year that AI researchers are making $1 million a year, even at a nonprofit. It's a little misleading because I think they're talking about OpenAI. But the point remains, most nonprofits do not have the capacity to get machine learning and AI, nor would they even know what to do with it. So that's when we got to thinking about 2011 or so, saying man, we've got all these technologists, all the data scientists and AI people coming out and doing great stuff in our free time, but not really knowing where to direct that to social impact. And social organizations who are suddenly machine learning rich, right? So but no one to help them do that. So couldn't we just get these groups together? And that's really how we came up with DataKind, a community effort to bring together data scientists, machine learning, AI engineers, pro bono with social organizations. So think of it like Doctors Without Borders for data nerds. Basically get to volunteer on a team and go work alongside Amnesty International or Red Cross to bring data science and machine learning to their work. And we've learned a ton about watching these things over the last 7 years. The baseline is it's fantastic because it gives data scientists and AI folks a chance to have social impact. But you also see social organizations kind of opening the door to realizing what this kind of sci-fi stuff that maybe they heard about could actually do for their organizations. So I'm gonna show you just a few quick examples, kind of a mix of DataKind examples and others, because as I mentioned, chapter 1 of this talk, what's the cool stuff we're seeing out there? So first thing is, first project I think of comes from the Molten Niguel Water District. Now this water district basically is in charge of making sure that everyone in Southern California gets clean water. Now the problem they had was if they need to figure out the demand that everyone has, because if they get that wrong, they've got to basically not just people run out of water, they have to go fill up a dump truck across town and ship it all the way down from Nevada or something to Southern California. Huge waste of energy, huge waste of money, and people don't get clean water. So they asked, could we figure out how to estimate demand more accurately, down to the block by block level? So we teamed them up with some data scientists, including the chief data scientist at Netflix. They got a bunch of data that the district had, as well as a bunch of open data that they found. And with that, they were able to build a tool that had incredibly high accuracy for doing block by block demand modeling. So now Molten Niguel uses this tool, which they kind of update as they get more data in it, does a bunch of predictive modeling, and they say they've saved $25 million a year and had way fewer of those cases where they've had to go fill up a truck. Straightforward example of the kind of stuff that we do in business applied right to a nonprofit. You take that data, build a model to optimize what they're doing, and lo and behold, people get clean water and you save a lot of money. Happy ending to that story. Another project I think is really cool comes out of Global Witness. Now, Global Witness's whole job is to defend vulnerable communities. What does that mean? Well, what you're looking at here is a strip mine. So there's a big open mine. And what if you look around the edge, you see there's a town and a village right near there. So if this international development project has any issues, if something leaks into the water supply and pollutes it, if people start acting unethically, what recourse do the people around it have? Global Witness. Global Witness comes in and says, hey, we will help represent you, we'll file complaints, et cetera, et cetera. So it's a fantastic program. It works great. They've been heralded as truly transforming a ton of different communities in their space and in their work. But the problem they have is they're we'd love to do this at scale, but we don't know where the mines are. Where are all the mines? That's actually a question that people don't have the answer to. And especially because if you look at Google Maps kind of view here, those are the mines that are flashing. They're not always easy to distinguish from non-mine. And so you can imagine one person at this nonprofit kind of scrolling through Google Maps isn't really gonna solve the problem. So we teamed them up with some volunteers, some coming from Foursquare, some from Google Brain, some researchers, and they built a classification algorithm, basically try to identify where mines are. And so this little screen here is sort of showing a visual representation of how much it's getting the mine boundary. This is as far as I know, fairly straightforward out of the box neural net. It's not super tuned. It's not that tricky to do. And they embedded this in this notebook for Global Witness. And so basically what it does, it helps them understand where it's got high probability of mines. So you can just zoom in and check, right? It's human in the loop. They're going to verify what they're seeing. But at least it cuts down that search. And so again, think if you're this nonprofit that's got like no people to do this work, this is like a huge time saver if you can implement this. So I love these two examples. Because again, I think if you're sitting in the audience thinking like, that's the stuff that I do all the time, that's not that on the edge of AI. It's like, you're probably right. Like, there's just so much low-hanging fruit here that you could bring to an organization that doesn't have that. So that's sort of the takeaway from those two that I like. I want to talk about two other projects that are kind of related, but I think emphasize something else, kind of other elements of what's cool today. So, whoa, it's weird that zoomed in. Hold on a sec. In the past couple of years, one of the big things that's been a lot more available, that's odd. You get the idea. This is identifying objects in video, right? So it's able to find people, it's able to see cars and stuff, and the fact that computers can do this kind of video object recognition on the cheap and more easily is fairly new. It's pretty exciting. So the question that we were wondering is like, how are people applying that to social impact? Like, we get it for self-driving cars, but like, where is this going to show up for social good and more equity? And one of the places that I thought was a really clever application was in conservation, and in particular in identifying types of animals. So a group called Wild Book goes out and built a bunch of classifiers for animal types, but not just animal types, individual animals. So on the right there, it's actually able to distinguish what type of shark, what specific shark that is. And so what they do now is they run this over just YouTube videos that people take, right? So if you're out taking a whale watching tour, right, and your grandma's filming the ocean, they're sucking that in and seeing if they can identify any of the animals they're tracking. And if they find one, I think this is just a nice little piece, they'll even let you know and give you a little info. Like this one, say, hey, we found whale shark P323 in your video. Here's everything we know about that shark from our research. And I like this response. Wow, and you're an AI. From all of humanity, please don't conquer us. It's funny, because it's like, of all the AIs to be conquered by, like, I want whale watching bot. I want whale watching AI to be our demon overlords. But I think this is great because here, I think there are like a couple clever things about this. One is this just shows like how much is sitting out there, right? They're scraping YouTube videos. That stuff's just out there. I don't think they have a partnership with YouTube. The code they're using is on multiple different versions are just out there on GitHub. So really just looking for a few people who could be that connective tissue, right? To say like this, plug A into B, and now all of a sudden you've got like a global tracking unit. Like, that's awesome. I think that's so cool. The last example I'll talk about is in response to a question we often get, which is when a lot of companies will come to DataKind and say like, well, what's the AI for good project we should solve? Like, where should AI for good go? And I think, people tend to answer healthcare, agriculture. Those are really easy kind of issue area answers. But I think there's actually a place for a lot of the stuff folks in this room are doing. And that comes to me around like generalization, transfer learning, I think has huge applied potential. And the case I think of came to us originally through this group, We Robotics. And then they're really fascinated. The way they started, as a side note, was that they were checking out disaster recovery in Nepal after the earthquake. And they noticed, they looked up and they're like, there's these drones all over Nepal in the skies, right? Like you can see a drone up there. And they're like, is there some kind of company doing this? Turned out they're just communities that are like, want to fly drones over their own cities to see what's going on. And the thing that really, I'm embarrassed to admit, kind of surprised me is I thought that was a very like US or first world kind of thing to have a drone flying around. But these are fairly ubiquitous. So We Robotics said, well, wait a second, maybe we can kind of create this network of drone operators who can help in disaster relief. And that's what they did. So they have these things called flying labs all over the world. They set up these, it's just for people who are UAV operators that want to help during disaster. They've got a code of ethics they follow. They've got tools and support, whole network. It was really great. The challenge they're now facing, though, is like a 20-minute flight is gigabytes of data. It's an oddly oriented camera. It could be changing. And so if you're really going to try to do disaster recovery from that, it's a tricky object recognition problem. And you've got to find buildings. You've got to find trees. It's non-trivial. So there's been some good progress. This is not a work we did, but this is a short demoing a vegetation detector. So this little red box is moving across some imagery. it's funny, they're showing it on a still, it's not the drone imagery. But in the top right, you can see it trying to detect the different types of trees, coconut, mango, papaya, and banana, and what it thinks the probability is. And so like this has been working pretty well in limited deployments where people can then say, great, let's just run this over all the video, let's kind of do an assessment of the agriculture and buildings and roads. But now the question that they're really tackling is, well, if this works here, like how hard is it to do transfer learning to take it somewhere else? And could we have this kind of global platform of building detectors, road detectors, vegetation detectors, so that now if you're in Kuala Lumpur or New Orleans and you want to use this approach, can you just fire it up and like retrain quickly? And I like get tingly about this work because to me, it's like the next step ahead. It's like, great, so we can classify, but could we make global classifiers that could help? And increasingly, there's even companies doing this. I just got turned on to Picterra, if anyone knows them. I think they're trying to do this as well in the corporate sense. So I'm getting carried away. Point is, there's a lot of really exciting stuff here to even look beyond just working with an individual organization, but actually thinking about how could these tools, especially with transfer learning, maybe scale out to disaster recovery across the world. And the last little note I'll sting on here is, the thing I love about this too is it's community driven. Like we don't want to, it's much better to me to live in a world where like people are doing this locally in their own context with their own technologists. So that's also really exciting to me that these tools could be shared around. So that's kind of like the quick like overview. Like, okay, so those are some cool projects. Just for like some stats, like DataKind, again, we're this global network of volunteers who do this. So we've got 18,000 volunteers. We've done about 250 projects, and that number is growing. We have a number of community hubs around the world of people doing this. So if you were to just kind of like tune out at the talk right now, I'd hope that you'd walk away going, awesome. Data science, machine learning have so many applications in nonprofits and social organizations. I want to help out. And if you want to help out, come by DataKind. There's other groups like Data Science for Social Good, the Data Science Bowl, Kaggle Data for Good, whole group of things that I think volunteers from outside companies can get involved with. Oh, what's not up here is Call for Code. It's a new one. So I hope that you just take, if nothing else, that. And you could walk away happy. But I mentioned there are 3 parts of this talk. So the second thing is, okay, if you're with that and you're like, okay, this is cool, the next step would be like, but how did all that actually happen? Right, like it'd be awesome if that was all just Kaggle competitions and like, you know, the Nepalese drone operators were like, here's our problem and people solved it. But like it kind of never works that way. And yet, nonprofits, foundations, and technologists that we run into always kind of expect it to. So this next stage of the talk is kind of like, here's what to expect when you actually want to make these projects work. People often are like, hey, let's just add a data scientist or let's AI it, right? There's no problem with that. Unfortunately, things rarely ever work that way. And the biggest reason is not a technology problem. I've found a lot of technologists ask, where's the most data? But actually, I'm going to probably preach to the converted in this room, huge number of people problems. And the biggest people problem, I have a whole rant about this, but I think I'm just going to trim it down for this talk to one thing, which is the biggest challenge right now is simply the people are speaking different languages. So what that means is right now, a lot of folks can't articulate their data or machine learning challenge. If you go to the average nonprofit and say, how could you use machine learning or AI, probably get blank stares, understandably, like most people don't know how to scope that out. So, and similarly, if you ask a data scientist or machine learning problem what the biggest challenges to affordable housing, they're not going to know either. So there's a whole kind of bridging effect first in just helping people understand what their problems are. In the example, it's not one of the examples I showed today, but we actually had this happen with the Red Cross, where they were trying to understand how, where fires were going to occur that they could prevent. And the first problem they came to us with is said, hey, we've got this great data problem. And we're like, oh man, what is it? They're like, we want to upgrade our access database from 2001 to 2003. Like, you ready for that? And we're like, whoa, well, like, we could do that, right? That's one thing we could do, but what are your objectives and what is really hard today? And through that kind of process, we help people kind of discover, oh, actually what would be helpful is a predictive model of where fires occur. So that's like step one, is like people just need some hand-holding. But the kind of soapbox I wanted to share with this group is, I think buzzwords are murdering our ability to do good work. Yeah, right? I've already used a bunch of them too, so I'm guilty. I just hope amongst friends. But like, The challenge for most folks outside, I mean, these rooms, we already have our own debates about now what's a data scientist or data analyst or research scientist or ML engineer. But outside this room, it gets way worse. And I'll tell you a quick story to illustrate this. We were talking to two NGOs in the same day. Both of them did disease surveillance. And that's a really important problem. Their whole job is to figure out where there are outbreaks before they become pandemics. We want those people doing their work well. And the first group, we said, I made the mistake of saying, hey, we do like data science and AI. And they said, we don't need AI. Like, there's no way we could possibly use AI. We have millions and millions of data points that we still need to analyze before we can use AI. And I was like, oh, wait, hold on. There sounds like there could be some good stuff in there. But of course, the notion was data analysis, that's data science or something else. That's not this. That's not machine learning, not optimization. So okay, so there's like a missed opportunity. That person's not going to raise their hand to say, how can I use machine learning or AI? On the flip side, we had a group that said, hey, we love what you're doing. We're not interested. We already have an AI team. We're like, whoa, and they're like a small nonprofit. And they're like, yeah, we have an AI engineer. I was like, this is awesome. Like, holy crud, what are you all working on? But their AI engineer, the person with that title, had been like a web developer, which is good, but like not necessarily the skills in like data science and machine learning. I don't want to disparage that person, just they're doing great stuff. It was just kind of a mismatch in that understanding. And again, it was enough for them to be like, oh, we don't need, like, we're good. So this is kind of like one of the things I think we spend the majority of our time doing is sitting with people for hours explaining where this technology could or couldn't be applied, and then really digging into the data with folks to actually figure it out. And so when we do this process, we spend about as much time scoping a project as we do doing it. And we found this framework really helpful, and also for explaining what we do. And it's what we call the 6 components of a great data science or AI for social impact project. And just really quickly around the ring, the components we talk about are a problem statement. So it's like a really crisp success. It's like, right, it's like your optimization, or the thing you're optimizing for, your goal state. And so it's not just we want to increase the amount of affordable housing. It's we want to increase this type of housing by this amount in this area, like getting really crisp. Second, of course, are data sets. But the fun thing is those may not live in the organization, right? They might be Google Maps. It might be someone else's data, public housing surveys. So it doesn't all live in one spot. Of course, data scientists or AI engineers, that's through partnerships or volunteering, show up. We talk about funding a lot, not just because things need money to run, but because funders are often foundations or corporations that see across the landscape. So they're really helpful in a lot of ways. We also talk about, let me go out of order here and go social actors. So that's your user in a sense, right? Your nonprofit, your government. But it's really important to like really name who that person is. Like it wouldn't be enough to say we're going to do disaster recovery by identifying buildings. It's like, well, who on the ground is going to use that? How are they going to use it? What kind of buildings do they need? Who are they? So really taking your user into account. And then subject matter expertise to be able to also step back and say, hey, if you're doing disaster relief, like this group does it this way, but that one does it this way. And if you actually tweak things slightly, that would be really helpful. And so we talk about this a lot because, this DK is for DataKind. People think of us as the data scientists, but like we actually think of ourselves as the center of this ring. Like our job is basically kind of like scavenger hunt and finding these, the ingredients for the recipe so that others can then do the work. So what does this mean for you? If you're out there, maybe the question to ask yourself of this is, which of these circles am I, or which do I have? And if you're thinking about getting involved in using AI for social good, how might I get the others? Because we really have rarely seen a project work super well without these. Sometimes you get lucky that they do all live in one organization, but it's usually kind of a hunting game. So I think just be prepared for that. All right, so that's one whole thing. Communicating with people, 6 components, track them down. Let's see, I'm just checking my time here. So one thing I want to talk about as well, of course, in our grab bag of discussions and making these things work well is like you should obviously be asking the question that is on everyone's tongues these days, that of ethics. We're bringing a bunch of different people together to build technology. There's a lot of ethical questions about what happens when you put them in the pot and stir, especially given the conversations that are out in the public today. There's articles like Silicon Valley is not your friend. Hurts a little, but okay. Obviously, my grandparents know about Facebook and Cambridge Analytica, and they're not happy about it. And increasingly, things like deep fakes, where people can create fake news and fake video and fake audio, is terrifying people because we're now in this age of disinformation, and AI is making it even worse. In fact, this has already been weaponized, right? So Emma Gonzalez, when she ripped up an NRA target, was very quickly remapped, ripping up the Constitution. and that, passed around as if that was what she'd actually done. I don't know if they used AI for that, but it's not that hard to imagine how this could be deployed. So rightfully, I think people are worried. And rightfully, we need to be talking about this, right? But I would posit, like my version of this talk for today, is that these are actually not the cases to worry about so much. Because these folks are acting in bad faith. The people photoshopping this want to push an agenda. The Facebook Cambridge Analytica thing, I could see that coming miles away. Anyone who was in this space, like they weren't concerned with what was going to happen. So I would argue a lot of this stuff is going to be kind of sorted out in the policy space. We need to talk about it. It is important. But I think there's a much subtler ethics question when we talk about doing AI for social good. So that's actually what I'd like to talk about. When the ethics conversation comes up, it's a big umbrella right now. The thing I'm really interested in is what happens when you try to do everything right and you still hurt people. So I love this Marshall McLuhan quote, "We become what we behold. We shape our tools, and then our tools shape us." Basic gist being, once you build something and put it out there, you may be designing it to do something, but from then on, how it runs determines how people use it and behave. And that was very true of everything from like a hammer to a desk, but now, of course, when we have self-improving, self-changing tools, this takes a new tone, I would say. So let me just talk about 3 places where if you're going to be doing AI for social good, we've seen people hit pitfalls and what we might do to avoid them. All right, first thing, bias, data, and design. This is the racist soap dispenser. So if you haven't seen this before, the basic gist is this does not work under a dark-skinned hand. So a person of color doesn't get soap, but a white hand does. Right? Like, yeah, it always elicits a few sad giggles, and even the person in the video is like being lighthearted about it. But it's not hard to see that this is sort of like a demonstration of like technology as like systematized microaggression, right? Like now I can't even get soap out of the soap dispenser. And what's interesting is like, of course, I don't believe the soap dispenser company like did this on purpose, right? There wasn't a design for that. My guess, I'm just totally conjecturing, is that someone built this and they tested it on light-colored hands. It wasn't tested on dark hands. The story is that this was at a conference where a representative from, I forget the country, but it's a country in Africa, came to visit. And so perhaps in that area, it's the middle of Iowa, and you just build it for the people in your town. The reason I bring this up is, of course, this conversation comes up all the time around biased data. This is not using data and AI, but when we go to build our algorithms, a lot of times we're just sucking up data from other sources, whether it's the way Google Maps is collected, health records, and there's, of course, huge amounts of bias that go into how that data is collected. So the remark again here, it's a little bit of an old saw, but it's that if we're going to be building data-driven algorithms, we have to be really thoughtful about where that data is coming from, what social implications were in collecting it, and increasingly, I think now as we're putting more and more trust in pulling in data from abroad, like really amping that up. And I think going back to the 6 components, having folks involved in the creation of that data or in those communities involved in the design is really, really critical and important. Second thing, got to talk about black box algorithms. So we can be quick over this one. The point is, of course, that if you can't open it and can't audit it, then it's hard to know what it does. And it's so easy to kick this algorithm when it's down because it's such a bad one. But this is thinking, of course, about Compass, the sentencing algorithm. So it gives recommendations for sentences when people come to courts. There are many problems with that, including bias, data, and design. But in this case, the part that stands out to me is no one knows exactly how Compass works. Its manufacturer refuses to disclose the proprietary algorithm. We only know the final risk assessment score it spits out. So there's a problem where truly an algorithm has been black boxed by a company and trade secrets. But just now imagine that mine detection algorithm we wrote. It's a neural net that we gave to Global Witness. How do you audit that? How do they look into it? What if it doesn't work? So I think even with the best of intentions, we have to be a little bit cautious about how we're making these things visible to people. And last but not least, hacking the objective function. So this is a classic story that happens, right? Is you design something like you say, hey, I want to see how this genetic algorithm evolves a walking gait, but I want it to walk so that none of its feet are ever touching the ground at the same time. And so, of course, the solution that won in this model was, well, fine, I'll flip myself on my back, and then none of my feet are touching. I'll walk on my shoulders. And of course, there's myriad stories like this where researchers are surprised to find that they've set what they thought was an objective function that was unassailable, only to find the computer doing something weird. There's a whole paper of these, which I encourage you to read, The Surprising Creativity of Digital Evolution. It's a collection of anecdotes. One of my favorites is the master tic-tac-toe player. So this is actually back in like the 80s. Researchers are setting up tic-tac-toe programs to play against each other. And they're learning and they're playing each other. And one tic-tac-toe player wins in one move every time. One move. That's better than I've ever played, right? Except with like my little brother just put an X over the whole thing, like done. Like there's no way to do that. So what's going on here? What they found was basically the algorithm had evolved to make the first move, it put in the coordinates, 0, 0 for the top left, 0, 1 to put an X in that square. So it would just say a million, a million. And the other opponent would expand the board to place that play and just crash and thus forfeit. So this is clever, right? So that's explaining it dynamically expands the memory. It's crashing, it's hacking its opponent, it's killing its opponent and winning. Now, that's a funny story because it's tic-tac-toe. But these cases are increasingly arising where algorithms are optimizing for things. And I'm actually very happy to say, I don't have a story like this from our own experience where something really tragic has happened with an algorithm we built and left in the wild. There is a book called Automating Inequality that many people have probably seen by Virginia Eubanks. It talks a little bit about some cases like this. But I think it raises a big question. Even if you are doing the most pristine work, getting unbiased data, building a model everyone can audit, and you just let it run, how do you avoid this case? Where is that insight? What responsibility is there when we're bringing this out into the world? Outside of maybe our research lab or our own companies? And I don't have a good answer, but I'm kind of positing this to folks. I think what people have seen work in the past is, honestly, just continual oversight, human in the loop kind of stuff. So recommendations of the first move at tic-tac-toe so that a human could say, well, we're not going to a million. But either way, I'll say, just sort of sum this up to all of this is I think there are huge ethical questions at a macro and micro level. The ones I'm most interested in is when people come together to do their best, what are the subtle ways that could go wrong? And I apologize for time. I'm just going to flash this up. I saw people have cameras. It'll be online. It's getting recorded. This is the kind of vetting and scoping process we go through with folks when we're bringing them on board for a project. And so the top chunk is just what do you do? What are you trying to accomplish? And we'll figure out if data and AI might be helpful. But then the second part is kind of these ethical design questions. So we want an algorithm to identify mine locations from satellite imagery so we can act to serve those communities. And so this is where we'll start to ask, well, what does success really look like? What if you only identified one more mine? What if you got a mine wrong? What happens? Who's going to use it and how? Is it you? Is it the community? Truly, who on your staff? Who's it going to affect? Again, if you get this wrong, if you don't serve a community because we missed a mine, what happens? And then who has the power to change it? What's the worst that happens if we fail? Is this critical path what you're doing? And worse, what's the worst that happens if we succeed? I don't think this is a plausible case, but could oil and extractive companies take the same algorithm to find competitors' mines? That's maybe not that bad, but could they find places to put new mines where we won't find them? Could they change their mines so we can't detect them? All those questions sort of have to happen up front, and I'd recommend they all happen in that 6-component framework. It's not just the technologists answering these questions, it's community members, social organizations, anyone who's got a stake in it. Okay, that was a lot, right? This is kind of a crazy tour through some interesting projects, some ethics stuff. I want to just close with one last little thought before I open it up, which is kind of what's next, right? Because if you look out at the AI for good landscape today, it's nascent, but there's a lot of activity. And in particular, see a lot of corporate partners doing projects. But the question that I'm curious about, I love all the projects that they're doing. I love their individual contributions through AI for Earth or Teradata doing projects or Google Cloud sponsoring things. But there's this sense where I'm there's got to be a next level, right? To me, these are all kind of drops in the bucket. If we're trying to save our oceans or stop climate change, it shouldn't fall on the backs of a handful of projects from companies or governments or DataKind, anyone. There's got to be something more serious here. So the question now, Act 3 of this talk is okay, if we already know there's cool ways we can use machine learning and AI, and we talked to some about the ethical concerns and capacity to do this, how do we kind of figure out what do we need to actually build at scale? And I don't mean technology, I mean institutions, to actually create a world where AI is being used for good. And I don't have the answer, but I'm very excited to announce we've been working with the Rockefeller Foundation, who just granted us a fairly generous grant to try to answer this question, to say, if in 2011 we were talking about big data for good, and now we're starting to see those things come to fruition in 2018, what conversations do we need to start now for 2025? What is that going to look like? In the same way that strategy consulting didn't exist in the 70s, but now McKinsey and everyone else has sort of exploded that field to where you can buy books on it, and there's consultancies, and there's social good consultancies like Bridgespan. What is this going to look like in the data and AI world? Is every nonprofit going to have an AI engineer? I don't think so, but then is it going to be AI consultancies? Is it going to be us? There's so many questions to answer and so many areas to answer it in that we're very excited to be embarking on this. I'm telling you about it because I'm hoping you'll be a part of that as well. The two things we do now are, number one, we're going to start this out by constraining to issue areas a little bit. So we're going to, as DataKind, be focusing in rural power, maternal health, food security, resilience, and US jobs. And within each, trying to understand not just what's the cool AI project, but where are all those 6 components? Where are the people, the ecosystems, the data sets all across, and how can they work together? Because right now, again, I think people are kind of distributed out in the space, doing great things, but what if we could bring them together? That's one thing. The other thing is, how do we replicate this? It can't just be us, shouldn't just be us. We've had DataKind chapters across the world who are volunteer hubs that imitate what we do. There are companies that do this work. What does it look like to scale that out? Is it that there's a pro bono arm of AI, like in law? Is it that there's university programs that train you to do this? Don't know. Probably a lot of options though. So again, I pose that out to the room. So we're really going to be asking this question, what are the institutions and networks we need to build so that all this stuff works well in the future? So with that, I know I'm running on time. So I'm going to stop here with just kind of summing it up. It's great. Jake, interesting or not interesting pile of stuff you threw at us. Dream it down for us. What can we do with this? The number one is, if you want to volunteer, if you're I want to use my skills for good, get involved. There's DataKind. I saw people taking pictures of the other groups. Be a part of giving your skills back. There's more opportunities than ever. There's the call for code that they're advertising in the pavilion. Get in there, do some good. If you're hey, actually, I'm at a company, I want my company to do more of this, or I run a department, I want to tackle big problems. Hey, come talk to us. We're looking for the people who are trying to do that. So please come talk to me. I'll put an email at the end. Or maybe you're hey, I liked that last part. I wanted to think about the future of AI for good. I'm just interested in that strategically, or I think I could help. Also contact us. I'm really excited. We're starting that conversation. We'll be at Bloomberg's Data for Good Exchange if anyone else is going to be there talking about this, so come there. And last, you want to hear more? Hey, stay for Saskia's talk. We got AI for Good all day. I think Mayhack's going to talk about human trafficking. Stay right here. Don't worry about the Xeon processor running this stuff. Come on, this is the place to be. And so if you want to talk to me, I'm over at contact@datakind.org. I'm Jake at datakind.org. You can contact me, but that's much more likely to get a response. But I'll close by saying, the point is, no matter what you do, please do something. Please let this not just be the conversation, or maybe if it even is that, have it with someone else. Because we're at this age now where it's this stuff is becoming ubiquitous. The skills, the data, and the problems facing our world, unfortunately. And I love this quote by Cicero, who said back in the day, you better take an interest in politics, because it's sure as heck going to take an interest in you. And I feel the same could be said 100 times over for AI. Better take an interest in it in society, because it's certainly going to take an interest in us. So whether you are a data scientist, a corporate partner, university, student, NGO, whatever, come aboard and get thinking about this, about what the next steps are, because really only when we all come together that we might actually live in a place where we're all watched over by machines of loving grace. Thank you. Spencer, when do I have to be off this stage? 35? Great. Would love to just open it up to any questions or comments, honestly reactions, because as you know, I'm trying a bunch of things out here and just want to hear what people are thinking. Yeah, red shirt there.
So to tie this into the last part of your talk, what's the future of data collection in the third world, for example?
Whoa.
I know that we talk about AI so much in the context of China or the West, but a lot of these problems that you're tackling are individual case by case. We'll bring the technology and fix this one small problem, but really the problem is that there's not a lot of data at all in some of these other topics. So do you see anyone tackling that issue, or what's the future of that?
Great question. I'll say what we've seen so far is the breakthrough areas that people have identified is, of course, mobile phones and smartphones have penetrated a lot of the world, and I think a lot of that data and the things being done on those apps are still underutilized. There's just not a lot of machine learning folks to use it, so I think that's still a little bit untapped, where they're in an area people often say, oh, there's no data here. There's sometimes stuff. I think the other big breakthrough, of course, we're seeing people go to is like satellite imagery and drone imagery, because once again, you're creating digital data in places that don't necessarily have that infrastructure. So to say, I think there's some of that. But you're not wrong. Like if you're going up to the mountains of Bhutan, like there's not always a ton of data. There's not a ton of infrastructure. There is a group, I wonder if they're still around actually, called Premise, that was specifically trying to create data for social change where there was no data. So there are some groups like that. I might be dated and don't know if they're still around. But I think there is a lot of opportunity there. And I think one of the things I would hope that might come out of this AI for Good 2025 conversation is if in this conversation, this process, the answer is that there need to be data creation techniques, then like, great, let's go say that to the powers that be at a Rockefeller or a Google and say like that's where the missing gap is. So I don't know if that fully answers your question, but that's my read on the state of play right now. Yeah, of course. Any other questions? Yeah.
Talk more about the resilience topic. I'm not sure if resilience has a character here, resilience has like a structural fear.
Oh, yeah. So it's really broad, and actually I'm not sure it's super well defined by right now. But the way that I think the way I think of this, is stability in the amidst shocks and stresses. So if you can make sure that people's livelihoods, economy, ability to get food, ability to get shelter is fairly constant or improving in spite of unrest, climate change, disaster, then you are achieving resilience. And so, yeah, sure. Any last thoughts? Oh, with a sigh, now I'm worried, but yeah, go for it.
Have you seen that play out anywhere where those stresses have been mitigated by these kinds of actions?
I think minorly, not at scale, but so there is a cool collaboration I saw between SAS and IOM. I forget what IOM stands for now. But they're an international relief agency. And it might have actually been that same earthquake in Nepal. So the challenge they had was they had to quickly rebuild structures. So they needed to make cheap structures, affordable structures that they could put up. And so basically IOM was like, we're gonna use sheet metal to do this. But they're like, if we order all the sheet metal to do this for the buildings, we will wipe out their supply. We'll actually cause huge economic disruption in this area. So how can we sort of cleverly source enough sheet metal to provide housing without damaging any economies? And so they teamed up with some SAS folks who said, well, we've got some data from the UN and we know about corrugated steel production here, there, and the other thing. So they optimized where that stuff would be routed in so it met budget and didn't disrupt the economy, and seems like a really good success story. So I think of cases like that a lot. I'm sure they have it on their website, so if I'm misrepresenting them, you might want to go check exactly how they did it. But yeah, I think there's a lot of potential for optimization and resource allocation that could be really helpful. Yeah, sure. Any parting thoughts in the back there? Yeah.
So it seems like there are a few different components that need to come together to create this type of solution. There's the data science component, there's the data component, obviously working with whoever you're trying to support to make sure that the use case lines up and is actually helpful. One other thing that I guess your take on is what about the data labeling portion? And I think it's interesting because there are not necessarily AI-focused data labeling efforts out there to volunteers, cat lab managers, things like that. But in my mind, I haven't yet seen these two things kind of fully come together yet, leveraging that volunteer base and then solving the data annotation problem. What are your thoughts on that?
I think it's a great question. I think it's totally true, especially as we enter a world where more advanced algorithms need more data. I don't have a good answer. In fact, actually, I was just in the expo hall, and the iMerit people tagged me. I don't know if anyone knows them, but they're like, we tag everything. We make everything labeled. So it's an interesting solution that needs to be solved in the market. I don't have a good answer. I think mostly we see people crowdsource it. Either the organization comes and says, we already tagged this stuff, or there's some indicator in the data itself that we can use as a predictor. Is the label. But or they crowdsource it to volunteers. But I haven't seen a good answer. So if you have a solution or thinking about how to make that available, make it happen. Cool. I think we could do one last one if people. Oh, never mind. I took you 5 minutes long, but it was worth it because those are all fantastic. Gang, thank you so much. And please, we're contact@datakind.org. We're on the web, datakind.org. Come find us. I really appreciate it. I hope that's just the beginning of the conversation. And more to come. Thanks.